All right. So, Vaibhav, are you able to hear me clearly? All right. So, let's start then. Okay. So, the word count example. So, yesterday we talked about why do we require pig, and pig is essentially a way of executing data flows in parallel on Hadoop. Pig executes something called pig Latin, and it runs on Hadoop, makes use of both HDFS and MapReduce. All right. Now, the typical word count example that we have been doing using MapReduce looks quite simple and quite intuitive. So, so for example, this line loads big.txt as one column only, meaning a single column, and that too is a line. And then it generates the words such that each row is a single word rather than a line. It breaks the line into words and then flattens it. You do not worry and do not panic if you do not understand any of this. Okay. So afterwards, once we have words, one word per line, all we do is group the words by word. Okay. And then and then we iterate over the words and count it. And once you have counted it, after iterating, once you have generated the count, then we print it. Okay. So few things to notice here is it is made up of four consecutive steps instead of a single step. All right. It's not like SQL where you have to do everything in a single shot. Also, few more things to notice that dash dash means comments. Okay. Any line which is preceded by double dash is a comment, and every statement results in another data set. For example, when you say load, it's resulting in one data set. Similarly, when we say for each, is giving out another data set. Similarly, group by is grouping the words by words and generating this, and then count. Now, the last statement called dump is the only one which is not generating a data set. It's printing it on the screen. All right. So everybody with me? Kiran, Vaibhav, Leonid? All right. Great. Great. So moving ahead. So here again, pig Latin, what we talked earlier and showed you an example. It allows you to describe how data flows, as in you saw that the data was flowing from uh, one data set to another and so on, and how should be read, how data should be processed, and then how data should be stored and so on. Okay. Few things to notice that there are no ifs and for loops. though there was a for each. And Piglatin allows us to create complex workflows so that multiple inputs can be joined and data is split into multiple streams. All right. So this is the difference between Piglatin and MapReduce. And in Piglatin, you have the syntax like join, filter, group by, order by, union. And while in MapReduce, there are no such thing called group by and order by directly. You will have to build it using the same MapReduce paradigm, right? MapReduce strategy. And even the joining was hard. If you remember our fifth example, the joining two tables was a difficult thing. All right. And after a point of time, the MapReduce gets monotonous. And if you are doing a larger work, it becomes quite a repetitive job, because every time you have to do group by, order by, or you have to join two data sets, it will be too painful in MapReduce. Okay, you can you can provide many kind of optimizations in Piglatin. You will see that as we go forward. Okay, such as rebalancing the reducers. So figuring out how many reducers to use and increasing number of reducers. Similarly, mentioning that how to join two tables in a various ways. Same thing, doing the same thing in MapReduce is a very difficult task, quite time consuming actually. Okay, so Piglet, since we will be coding Piglet in, it will be easier to do the error checking before even execution. Okay, because in Piglatin we express our data, and therefore it's easier to basically do the error checking. Now your data, your things are not clear to MapReduce, therefore MapReduce doesn't do any error checking. So the way SQL can give you the syntax error, okay, in the same way Piglatin can also give you a syntax error in your queries. All right. Again, let me just, yeah. So MapReduce requires more effort and time. For example, 170 lines of code is for word count, while their word count took only around 6-7 lines in Piglatin. Okay, therefore it has low cost to maintain and low cost to write. I think this Piglatin versus SQL we will do again at the end of the session. I think I'll just drag it to the end of the session. Yeah, because it would make sense only once you have gone through the full comparison. All right. So there are many use cases of Pig Latin, starting with ETL, as in you can use you can use Pig Latin to do the extract, transform, and load of the data. If you have to do the research on data, Pig can be quite useful. Similarly, if you have to do the iterative batch processing, then that also pigletin is quite useful. All right. Okay. So before we move forward, let's understand what has been the basic philosophy behind pig. So first one was pig eats anything. These are the very important aspects. Unlike our SQL data, our data in pig need not to be completely structured. So pig can eat a relational data, nested data, or unstructured data. Nested data as in the data, if the data is in the form of JSON, that also can be handled here. Next is pigs live anywhere. Okay, so it's not only for Hadoop, it also works for few more systems such as Apache Spark. So pig is not only for Hadoop. Okay, so it is designed for parallel computing, or it is designed for distributed computing. Next is pigs are domestic animals. They're controllable, provides custom functions in Java. So in case there is a function which is not available in pig, you can create that function immediately. And you can also mm, create custom load functions the way we had different kind of uh, input uh, input classes. Okay, so the way we had input format classes in MapReduce, in the same way we have input custom load and store method in pig. Pigs have been designed for performance. Okay, pigs fly. So the pigletin has been designed for performance, and you will see how. Pig is just a client. It doesn't have a server. So you can simply download from the release and extract it and make it run provided you have set your Java home. It's just like just like a Java program. To test whether everything is okay with your installation with your Java home path, try running pig-x local, and if it's working, that means everything is great. Next is you have to set the location of configuration file of Hadoop by setting pig underscore class path, and that's all. Okay, it's not too difficult task. And once that is done, then you should be able to get a pig command prompt. All right. So you can have a look at. Okay, so you can SSH into this, into any of this, or you can simply go to Hadoop 3, and from there you can do the SSH. From here you can do the. I'm still using the older one. Okay, so let me SSH to Hadoop 1. All right. No, this is, I think, yeah, I'm at Hadoop 1. All right. So you can log into any of Hadoop 1, Hadoop 2, or Hadoop 3. In case you're getting a memory error, try logging into different system. Because if multiple people try to log in at the simultaneously and run pig command, generally the memory becomes a little bit constrained. All right. All right, so data has been uploaded to user data, as in the Hadoop. So, so this is the command prompt from where we can type all the big commands. Also, if you are not very comfortable with this kind of a prompt, you could write your big query using Hue. Here, you can see the pig here, and you can create your script here. All right. So Kiran's question is, pig internally writes MapReduce programs. Um, it doesn't really write a MapReduce program. Okay. It basically generates the MapReduce code. Okay. So you cannot, if you try to find out where is my Java code, you cannot find that Java code. All right. But internally, yes, pig generates the MapReduce jar, which gets executed on the node. All right. You will see that. Great. So this is how you can get started. Now, other than the normal mode, which I'm running right now in this, where I just typed pig, you have pig minus x local. Even if you have no Hadoop installation, you can run pig in the local mode so that you can test the the script locally, and also sometimes it helps us doing the improving the development pace. Okay. And what is a pig script? All the commands of a pig written in a file is called a pig script. You can execute that by using pig and give the script location, and it will get executed. If you just are interested in single command execution and you do not want to get into the prompt, then you can simply say pig minus e and then give the name of the command, and that's it. All right. So a little bit introduction about this command prompt. Let me exit from here. So again, I go back to pig instead of local. In case of pig minus x local, any file you try to refer will be on the local file system. If you try to run pig on usual mode, then every file you want to refer to will be on the HDFS. So for example, if you do ls, right now you will be seeing the HDFS. Okay. So you could also say things like cd data, and if you do ls, you see the data related to in this folder. Okay. And cat a will show you the data inside a. So probably this is the coolest interface for you could have for file system. Okay, you could say it's quite simple. I find it very comfortable, so whenever I have to do a lot of HDFS manipulation, I use pig. Okay, so from here you could do other things also, such as killing a job. If there is a long running job, you can kill a job from here. Also, you could load a script using run external script using exec or using run. Okay. So basically this pig prompt is quite useful in because it allows us to execute commands interactively. Okay. Next is the basic construction. We have already talked about single line commands. Multi-line commands are like C++, starting with slash star and ending with the star slash. Okay. Although pig and pig is case insensitive, the keywords can be capital or lowercase, but UDF, the user defined functions or internal functions, both are case sensitive. All right. So let's the way we'll be learning is we'll be going back and forth with the syntax, with the basics, and also try to build a program. The best way to learn a new language is to look at the code and trying to execute the code. Okay. So here what we are going to do is, let's say we have this data NYSE dividend. I'll show you what is there in this data. So if you say tail, is there a tail somewhere? So tail is not a command here. Okay. So this data, which is let me also open Hue, that will make you comfortable. So if you go into this particular file, so as we told you that under data we are going to keep pig data. Okay. Here is all the data that we requires for today. So NYSE is one such file containing the New York Stock Exchange dividends, and the values are tab separated. Okay, the separation between one column and another is tab. So all we want to do is this is our symbol. For each symbol we want to compute average value of stock. Okay, that's all we want to do. This is a very trivial task in SQL, and so it should be. And Pig makes it possible to do it in a very simple manner. So at the end of the day, what we want to do is, for CPU we want to find average of all of this. CSS, we want to find the average of uh, 0.41 and 0.43. For CIF, 0.029 and 0.028. All right. So that's what we want to compute the average. It's quite straightforward actually. The way we do it: first, we load the data, then we dump the data, then it's not required, this is only for testing. So, first we load the data, and then we group the data, and we iterate over the data and compute the average, then we store. Alright, just a second. Hi, I'm sorry. I'm really sorry because there was somebody at the door. So they are not in sorted order, Kiran. Kiran's question is, are they in sorted order? They are not in sorted order. Okay. So again, what are we going to do first is we load the data, then we check whether the data has been loaded correctly, and then we group by. After group buying, we are going to compute the average, and then we are going to store the average into the HDFS file. All right. So the steps are simple, just that uh, in case of SQL, we could have done all of these 6 steps all of these 4 steps. These 2 steps are not counted. So all of these 4 steps we could have done in a single shot. But here we do it stepwise. Okay, that gives us more comfort. That gives us more comfort, and let's try to execute this. Okay. First, we are loading data. We are, and then let's have a look at what is there in, if we say dump divs. Okay. So you can see that even when we said dump divs, it executed the MapReduce engine and it's running the MapReduce engine. And it has given us the URL to track exactly the way we got the URL to track when we were doing when we were doing the when we were doing the MapReduce. Okay, so okay, so you can see that MapReduce is getting executed. All right, and this is the data which has been loaded, and also we can have a look at what is there. Yeah, output of the dump is displayed here. You see, this is the output of the dump. Okay, so going ahead. So when you say explain, it means that it will tell you what is the plan. Okay, you will understand it a little bit more when we talk about it later. So uh, uh, we are basically loading a file into a data set, and then this is the data set where the file has been loaded from this location. And this location, please remember this, I'll emphasize a little bit more. If we are running normal pig, then this location means HDFS file. If we are running pig minus x local, this location means local file. Pig will search in the local file if we are running in pig minus x local. Otherwise, pig will search in HDFS. Okay. Next step is we group the data. So Webber's question is, what if the file is not separated? Tab separated. Is there a different command and argument? Yes, we'll come to that. Okay. So if we have to load a comma separated file, we could use another command. All right. Now we can say group by particular thing, and afterwards we could compute the average by iterating over all the groups, and then we store the data into some location, or we could simply dump also. Okay, it says that already that file exists, So we can say, what is the date? We'll say, what was, okay, let's call it 25 July. Okay. Now also notice that all the steps up to here, day, load, group, for each, all of those finished very, very instantaneously. Okay. The only time which is being consumed is in store. Okay. That looks awkward at first, but the truth is the whole thing, the whole plan gets executed only when you try to store or you try to dump. Otherwise, these steps are basically instructions saying divs means load this, groups means group this. Okay, it's like views. We are creating sort of a views on top of our um, another set of views. So div is a view, sort of a view. Similarly, grouped is a sort of a view. And when you say store, then the whole process starts. Then when we say store averaged, it would go back and try to compute the for each, and for each it has to first compute the grouped, and then it'll, so it goes back and execute things which are required for doing this computation. Okay, so mm, I mean it gives you two things, I mean two ideas. First, whenever you are executing average, then the flow is not linear. Okay, in pig it's not like in normal programming, as and when the statements get executed, some action is happening. Here that is not the case. Okay, action will happen only at the store. If you do store twice, then the whole MapReduce process to do the whole process will execute twice. All right. Second thing is the data is not really cached here. These are just instructions saying grouped equals to group this. So whenever somebody tries to dump group, then this process will start. Okay. So Matthew's question is, what is the purpose of explain divs? So if you do explain anything, explain any data set, okay? If you do explain any data set, then you will see what? Explain, and not this, explain averaged, okay? Explain averaged. It shows you the full detail about what is going to happen when average is executed. When you try to dump average, it will try to, it will show you the full detail MapReduce plan on what could be done. Okay. 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 No problem, Kiran. So yeah, to see the full detailed plan, you use the explain or describe. All right. If you go into the file here and if you go into data out, all right, and if you go into average 11 July, so here it has done the job and stored our data. Okay. So we were able to successfully compute the average. All right. Now back to the basics. Back to the basics. So that's how generally you learn a programming language, new language specifically. You see the example, you see the bigger example, then you get back to the basics and then get back to the example. All right. And that's how we are going to go. And now Kiran's question is, do we generate MapReduce for each steps? No. Good question. Good question. So Pig does a smart thing and figures out how can it basically when it looks at average, it looks at all of these statements and it may generate more than one map reduce, or if it requires, it will generate only one map reduce. So when you say store averaged or dump averaged, it will look at all the dependencies of averaged recursively and then find out what are the minimum number of MapReduce that need to be generated. Okay, and it doesn't. So it does a lot of optimization to for computing the MapReduce. Okay, so again another good question from Kiran. The question is, where is yeah. So Pig works on full data or process record by record. So it does the record by record processing. Okay. Just like SQL, where we apply anything and it happens on the record by record manner on the full data. You will understand that better when you look at the statements. All right. So these are the basic data types. So Pig's data types are of two kinds. One is scalar, that is basic data types. Another is complex. Okay, basic data types are mostly like Java data types. You have integer, you have long, you have float, meaning double decimal, and you have double, and you have character array, and you have byte array. Byte array, as in it has got binary array. Okay, so okay. Now there is one more question from Kiran. Okay. Pig will be executed only on one node, or will it be copied and executed on all other nodes where data is splitted and stored? So Pig will do like a good Pig works like a good programmer. It takes your Pig script and converts it into MapReduce, and internally it schedules that job onto Hadoop, right? So rest of the process is just like MapReduce, and therefore it gets executed over all the cluster. Make sense, Kiran? All right. Though the compilation of Pig script and formation of MapReduce will be only happening locally on the single machine, but rest of the execution of MapReduce is the classic, all right. The next set of data types in Pig are complex, and the complex data types are made up of scalar as well as other data types. So the basic one is map. In complex, there is one data type called map, and a map is basically a collection of key value pair, key and the value pair. So there are a lot of key value pairs in a map. All right. For example, name hash Bob, age hash 55. So name is one key, value is the value for the name, and there are basically two pairs of key values. Okay. Few things to note here is the key for this data set is a character array. It cannot be another complex data types, while the value can be another complex data type. Okay. Here a Bob could happen to be a simple string, which is char array. It could happen that Bob is another map. All right. So so here instead of Bob, we could have another complex map is starting with the square bracket, something like this. Okay. You could have um, my key and hash my value. So you could have had this kind of complex structure as well. So while the value can be a complex object, the key has to be a basic or scalar data types. Okay, so map is clear to everyone? Deepak, John, Kiran, Leonid, Matthew, Vaibhav. It's a collection of key value pairs. Then comes tuple. Tuple is like is a ordered collection of values, just like an array. So tuple is basically a ordered collection of values, and the best analogy you can take for tuple is a row. If you have read tuple algebra or something like that, each row in 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 database table is actually called a tuple. Okay, so a tuple is basically a row, a collection of values, and you can either refer to each individual value using index like 0, 1, 2, 3, or you can refer each individual value with some name. So when you start referring it with some name, it will look like okay, it will look like you have a map if you have only two values, but there is a huge difference between tuple and the map. Okay, so a tuple could be any number of values, and each value is not a key value pair. Each value is can be either scalar or could be further complex data type. For example, in the fifth line here says this is one tuple. Okay, this is one tuple. First one is a char array, then there is a integer, then there is a float, and then there is a map. This is another member of tuple, and this is a map. Okay. Next is a bag. Bag is the equivalent of a table. It's a collection of rows, meaning collection of tuples. All right. It's a collection of tuples, and you can also think of it like a set, or you can think of it like a set or data set, like a big data table, and it's made up of tuples. It's an unordered collection of tuples. The way database table is an unordered collection of rows, similarly a bag is an unordered collection of tuples. For example, you can have, so this individually, this one is a tuple, this one is a tuple, and this one is a bag. All right. All right. The bag has another property, that When we deal with bag, we don't have to worry about memory being consumed by the bag because it spills over to the disk and it is heavily optimized. Okay. Yes, that's correct. Weber, name was the key and value was Bob. That's correct. All right. Now we have a question from Kiran. Good questions. And so each round brackets is a tuple. That's his question in this example. Yes. All right. And in this, 1, 2 are tuples. Yes. But generally, you cannot write it like this. You'll have to write it like this. All right. You'll have to write it like this. All right. Yes. So Vaibhav's question is, so map will be two pairs? Yes. Not two pairs as in one pair. Map will be one pair. All right. Okay. So are maps and tuples always stored in memory? Uh, Actually, not really. It happens during the time of the computation when the things are being executed in on each node. Only at that time these maps and tuples are loaded into the memory. Okay. While I think map is not stored in the memory. I need to check. So tuples are loaded into memory. Okay. Need to check about map. Okay. So internally when it's dealing with the tuples, it will load tuples into memory, but it won't load the maps and I think maps and bags into memory. That's correct, uh, Weber. So tuples can be more than two columns and i- include map. Yes. And then, okay, okay, bag will be multiple tuples. Bag will be multiple tuples. That's correct. That's correct. Okay, good, good. Okay. Bag will be multiple tuples. One pair of key value like name, Bob, and second pair of key. Yes, that's correct. Great. All right. All right. So these were the data types in Pig, and when we deal with it, we will understand more about them. So two pairs in map. Yes, we can have more and more pairs in the map as many as we want. Okay, we can have more and more pairs in the map. I'll give you an example, and you will be able to see that. So we can have as many as possible key value pair collections in the map. Okay, we could have something like name is this and education is say 10th or hometown is somewhere, so we could have that. All right. Yes, so you can look at it like a big array of key value pairs, and accessing in each individual element is really fast in a map because we always access it by the name. All right. The only difference is uh, you can when talk about this, we cannot say map and access the zeroth or first element of a map. Okay, we always have to we always have to access the elements, always have to access the elements using the using the name. This is like using the key. All right. So basically that's the difference between array and map, although it's a good way to think of a big map like an array. But in case of an array, we can iterate over the values using indexes. We can say, give me zeroth element, give me first element, give me second element, but that you cannot do over the map. Now we have got good questions. Great. Good question, Vaibhav. And moving ahead. Now, address hash, house number hash 100, and city hash uh, Delhi is a valid map. Yes, it's a valid map. So here, when we, okay, let me try to put a square bracket to give a sense of it. Okay, so it's a map having one key value pair. Key is address and value is a complex object. Okay, and this value object has got key and the value. Okay, the complex object, the value object itself is mm, another it has to be square like this. Okay, because I think we are talking about a hash map, right? All right, so the value can be another map in the map in a map. Good going. All right, so that was about data types. So each value, when we load the data, we say that when we load the data, we mark the values with the data types. But good news is that pig doesn't care much about that. Okay, so while loading the data, say we are loading New York Stock Exchange dividends, this particular file, we can say that it's made up of these columns. Okay, so there'll be many rows in this, and each row will have these fields. Or we could just skip the data type and let pig figure out the data types. Next is that next is that we could also skip the field name and later on refer the fields by $0, $1 or $2. Okay, so that we can do at a later point of time. So we could also say very simply that dividends equals to load NYSE dividends. Okay, all right. Schema declaration for complex data types. You can see that. We can say that my field A, like the exchange here, without the data type. So I think a better way of doing it would be by listing things. All right. So we could say this, or we could say load this, and we could so simply say things like this, or even we could do the partial one, as in for some fields we mention the data types, for some we do not. Okay, like here. See that? So these all three are valid statements. So when we are loading the data, we don't always have to specify the data types. We can also cast it later. Also, when we are declaring a data type as complex, okay, we could define the data types of internal values. For example, when we are saying my A is a map, so we could either say that A colon map, or we could go one step further and tell Pig that my A which is a map, my A which is a map contains contains a tuple, a tuple having integer and byte array as the value. Okay, while key we know for sure it's going to be a string. The value is what we define here. Okay, so we can say that our map is made up of tuple, has the value of the data type called tuple. All right, or we could say our map has got integer. Instead of this, we could also say value is integer. Okay, based on our requirements. Similarly, when we are saying that our particular field, here we have told that our particular field is a char array and float. Similarly, we could have also said that our particular field is a tuple, or we could go further and give the names to each individual fields of a tuple, like X is going to be the first column, Y is going to be the second column, and so on inside the tuple. We can go further there and tell that our tuple is made up of integer, byte array, etc. All right. Similarly, a bag is while defining a bag, we can either say that our field is just a bag, or we could go one step further and tell that our bag is made up of tuples, and whose data type is this? Whose data type is this? So A is a bag made up of tuples having two fields. Alright. So this is how you define the schema, or you could partially define the schema, or you could completely skip defining the schema and later on cast the data or parse the data to form a valid data type. Okay. Now we have a question from Kiran. Let me just go with the question. All right. Yeah. If my file has multiple columns like New York Exchange file, and if one column has numeric values in some rows and string values in some rows, then how does Pig identify the data type if we do not provide the data type? All right. So the simple answer is Pig doesn't. Okay. Simple answer is Pig doesn't. So in case you try to cast an invalid value, Pig will give you an error saying cannot cast such and such value. Also, Pig will tell you that cannot compare such and such value, and therefore it's not doing the job. All right. So at the runtime, you will get an error. Okay. You will get an error at runtime. All right. Great. So, okay, Matthew, did I miss anything? All right, nothing. Let's move on. Okay. Now, once we have defined the data types, uh, the next step or the first step in case of a pig Latin is load. Okay. So you could either say load my file, or you could say load my file using. All right. So, sorry. So when loading the data, you could either say simply load my data, or if your data is not tab separated, if your data is tab separated, it will automatically split the fields based on tabs and generates the tuples for each individual uh, row. So records are by default, when we load the data, the records it expects to be separated by new line, while the fields in the records it expects them to be separated by a tab. But if your data is separated by some other field, say comma, then you could use big storage comma. All right, like this. So I hope that answers Webber's question. Okay. Also, please note that this big storage comma is not really a CSV parser. It's not a comma separated values parser. Sometimes inside the comma separated values, there could be a comma in the field, in the value itself, and it's surrounded by double quotes. So that kind, in those scenarios, this big CSV parsing will not really work. Okay. Sorry, the big storage comma is not good solution, but you can use something called CSV parser provided by pig. You can take a look at CSV parser and that should give you the answer. All right. Next is, all right, there are two questions. So if we provide the data type as a string, that it will work. Yes, it will work. String as in char array. Char array. And for unstructured data like music, video, and image, the data type is byte array. Okay, blob basically. All right. So if your data is separated by comma, you could use big storage. Otherwise, if your data is proper CSV, then you will have to use CSV parser provided by pig. And then we have, if there are multiple files in the folder, you could also say load and put the star there. It's a wildcard character. It's not really a regular expression. And in case you are trying to load data from HBase, HBase is another database which runs on top of HDFS. So you can churn the data located in HBase using pig. All right, using pig. All right. Now, okay, as we have already told that in case your date, you can also define the data type upfront if you want. Next is that in case you are trying to load the JSON data, you can do that also using JSON loader. Okay, so each individual element, in case the food, say for example food is a map here inside JSON, you can mention it accordingly. Okay, using the complex data types, you can load a complex JSON object. All right, that's about loading the data. Once you have loaded the data, you can simply say explain dataset, which will give you the clarity on what is inside it. When we dump this data, what is it going to happen? When we store the data, what is going to happen? That's what explain gives you. What are the steps to that will give this reach to this data set? Describe data set will give you the data set, the schema of the this data set. For example, let's have a look at, so explain gave us this detailed plan. This is a map reduce plan. And so you can see that there is map plan, there is a combiner, there is a reducer. So internally it does everything for you. All right. Next is that, so schema. So we can say describe averaged. Okay, you can see that it is telling you that average is having two columns. Okay, average is a bag of these two columns, group and one double value. Okay, this first column has got the column name called group, while there is no column name for the second value. That's what this tells you. And the data type for first one is a byte array, second one is a double. All right, everybody okay with this? Okay. If you want a syntax highlighting tool for Pig, these are the various syntax highlighting tools available. All right. So we talked about load, and the opposite of load is storing the data. So you could simply say store processed into one HDFS file, and similar to load, you have this using pig storage, or you could say using HBase storage. Then in that case, it will store the data in HBase. Here, it is going to store the data. It is going to store this particular data set called processed into an HDFS file in processed. In case you are not specifying the absolute location, the relative path will be from your home directory or the current directory. And then using, if you do not provide this statement called using, then the data is going to be tab separated. Since you have provided using pig storage, comma, the data that is going in this HDFS file is going to be tab separated. All right. Now, sometimes you just have to see what is there in the data set. You can, for that, you can simply dump the data. It's equivalent of print and is useful for debugging, or you can, if you are executing things from command line, you can use dump to save the data onto some file locally. Okay. So when we say store stores the output onto HDFS. If pig is running in a normal mode, if pig is running in a local mode, store will store on the local file system. Dump will dump the data and give it on the local file system. Okay. So if you are saying pig -e dump my data, then and then you redirect it, then you will be able to store it using into another file. Okay, so if you go back and whatever we did here, so let's take a case of this one. So if we put these two statement into a separate file and we execute it like pig and script name, then the dump will give the result on the screen, and if you redirect it to some file, then it will get stored in the local file. Okay, now all right, so any file next question from Kiran is, all right, let the questions keep on coming. Any file is stored in HDFS will again is split it by a replication factor. Not is split it, replicated by, copied by a replication factor. That's correct. So whenever you are storing the output of pig, it is going to get replicated and the usual HDFS process will start. Good, good. All right. All right. Does that answer your question, Kiran? Great. Let's move on. So we talked about store and dump. Now the next statement is for each. For each is like select statement. Okay, we go from top to bottom, one record at a time, and do the generate, as in give me these columns. That's all for each does. Okay, it does not do any group by, it does not do order by or anything. All it does is takes an expression and applies on each record one at a time. So for example, for each divs generate ticker comma value will convert divs, will project divs such that there are only two columns in the output. If divs had hundreds of columns, but values will only have two columns called ticker comma value. Okay, so that's the role of for each. You could also apply things like square root of ticker or summation of this plus that. So those kind of things for each can do very efficiently. Okay, so if you have to transform all the records of a data, then we can simply use for each. All right, Leonid's question is, does it imply that the values of, okay, does it imply that values variable is of type bag? Values variable is of type bag. Yes, that's correct. Same is the case of divs. Divs is basically collection of tuples. Okay, each tuple is represented as these four values. Okay, so we are applying for each on a bag to give out another bag. All right, and then we can dump that bag. Sounds sensible, right? So when we load something, it's basically a bag of this tuple, this tuple. Makes sense, Leonid? All right. Now inside a for each, Just like in select, when we say select star, similar to that, we can also select multiple columns while doing the for each. For example, all the columns, like let's take a look here. Just a second, I think. All right, now it's okay. It's okay. There was a flickering happening in my Chrome window. So, all right. Next question from, does it have any benefit to strong type versus uh, strong typed values? Okay. So, good question. Good question. So, it's a very good question saying there are two ways we have talked about. One was that we will not specify our, while loading, we will not specify the data types, and other was we will specify the data types. So as a general thumb rule, when you specify data types, it does help a lot. It does help a lot. So if you know for sure that the data is clean and data will be loaded correctly, even if you specify the data types, then specify the data type, because that will make the things a little faster. It will avoid the guesswork. Great. All right. So let's say you want to compute close minus open values. So it's pretty simple. You say for each prices generate close minus open. All right. Next is that in case you just loaded like prices equals to load something, and you don't know the name for the fields. In those cases, you can say $6 minus $3. Okay. Next is that in case you only want the columns start up to open, okay, up to open, say exchange symbol date open, you want only those in the output, so you can say dot dot and open. If you want only the columns from open to close, you could say open dot dot close. In case you want all the columns after and including volume, you can say volume dot dot. Okay. Next is the a few questions for you. Just a second. Yeah. Yes. We can do $3 dot dot $6. That's correct. All right. So here is a little difficult question for you. That when we are doing gain equals to for each prices and generate close minus open, and we say dump gain, do you think there are going to be any reducer code? Will there be any reducer generated for this? As we talked about, anything we do in pig, everything is going to lead to map reduce. So probably for every problem we will be having maps, but do you think there'll be a reducer side code for this particular statement? Great, great. So Webber says that mapper will compute, so no reducer is needed. Correct. So if you think about what's going under the hood, if you had to write the same code using MapReduce, all you need is a mapper, not the reducer, because reducer you need only if you are doing some summarization, grouping, or or some sort of summation. Okay, so if unless you are doing the sorting or you are doing sort of aggregation, you don't really require aggregate this reducer. All right, great. Same is the answer from Matthew and Kiran. So Leonid's question is, okay, let me clarify this. All right. So logical answer is no, but isn't one reducer used by default in MapReduce? So when we are coding, when we are generating our MapReduce program, Hadoop does the reducer part unless specifically you turn it off, and Pig turns it off by default because it is unnecessary overhead. If you do not want your output to be sorted or aggregated, you don't require a reducer phase at all. All right. Great, great. All right, so we all agree on the answer no. Next is that in case you want to iterate over the data further and the data is of complex type, let's take a case of this baseball. Okay, let's take a case of baseball, and I think I should show you the data. Now here is some data which will make you a little dizzy because it is little complex and is in the form of our pig's data type. All right, let's have a look at it. Let's try to reformat it. So here this is one bag, okay, and this is a map. So it's basically the data about baseball teams. It's a name of the person, name of the player, the name of the team, and then the character traits. These are the traits of the player, and then a little bit history, the scorecard of the player. That this player has played these many baseball games and he was hit by pitch these many times, and so on. I'm not really a good I'm not really good at baseball, so uh, my terminology might be a little wrong. Okay, but the example is good in the sense that it's a complex example. And as we have talked about, uh, when we serialize the data or deserialize the data, Pig tries to understand the data complex data based on curly brackets, round brackets, on square brackets. Okay, so we will load this data. We will load this data and then try to compute few things. So, so if we are, let's take a case of this one. This should do a good job. So we are saying load this baseball file. Okay, we had to do cd data and then load that again. Yeah, because our data is in the data folder. So here what we are saying, load this file, and we have got name as the first, team, traits, and batting history. And into b-ball. All right. So in case we want to compute, we just want to find out the batting average of this person. So what we could do is, for the column called bat, the last column, we can access just a particular value out of the hash map, which is which is betting average, for example. So in this, we will we will try to find out the betting average of the players. So for London Powell, the betting average is 0.229, while for George Posanda, there is no betting average, and so on. You can see that. So it's only for few players. Okay, having a map helps us in dealing with these kind of problems with the data. So you can see that. Now, if we say dump AVG, we should be able to see the batting average of the players. All right, you can see that it has computed the batting average of various players. All right, you can see that band job is 0.26 and this. So it has basically projected only those last value. If we say last block, then we will be able to see band job wrist and what was the it was 0.26, and for Joel it was nothing. Okay, you can see that. So we could manipulate data of the complex data type using pig in this following manner. Also, we can do the projection in also. So for example, if you have this input which is made up of xyz as tuples, you could generate only two columns out of it using this, and you could generate only few columns out of the tuple. All right. Next is that similarly, if you want to do the projection on the bag, if your data is made up of the bag and you want to generate only one value, you can only pick that value. So that way you'll be able to transform your data from one form to another by using the projections. All right. So if you want to generate x and y, either you could say b dot x comma b dot y, or you could say b dot x comma y. All right. So that's for each on top of the complex data types. Also, if you want to do the computation, you can do the computation in for each. For example, we are saying generate dividend in 200 and give it a name called dividend, and then another column. Okay, so you could do the computation inside for each. And the functions, the way we are doing multiplication here, you can call multiple functions inside a for each, and these are the various functions available to you. You can see the mathematical function, you can see the string functions. Out of this, probably the regex extract will help you a lot when you are parsing the input data. You can load the raw data using load statement, and then use a function called regex extract to extract the data. For example, if you have this field, say there is a field xyz, and you want to convert that into into multiple fields, you could basically say put a regex, and how whatever the captures are there, for each capture pig will create one output field. Okay, so you can break it down quickly into host and port by using this regular expression. Okay, all right. So the regex extract is just to pick up one value. So when we say one here, the first one will get picked up, which is IP address for all the records. And if you want to break it down into multiple ones, then you can basically use extract all. So it will basically, it will, what it is going to do is, I think we don't have that example. Yeah. So if we have the input, our input formed in certain fashion, let's say Sandeep colon Giri, comma, comma 13. Now this is the kind of data we have. Let's say Vaibhav, comma Srivastav, okay, comma say 15. I don't know what is this number. I just put some number. Now, if you have to load this data, this is your data, right? Now you cannot have comma or colon as the separator. So what you can do is my data set equals to load data. You simply loaded the data, whatever it is, as line. Okay. So basically, it's made up of one line at a time. It's not passed yet. It's as simple as this one. Next, you can break it down into another form by using for each x, generate, generate, for each x, and then generate. You could pick regex this way and say $0, all right? And then we can say here regular expression saying anything anything followed by colon, then anything followed by comma, and then 0 to 9 plus. All right. So this way, and when we run that, uh, it will give us, it'll, when we say dump y, it will give us different columns. Okay. It will basically convert it into Sandeep, and it will be Giri, and it'll be 13. It'll be all right. So basically, it helps us. This part of pig we call it as ETL, as in extract, transform, and load. So you don't really need to clean up the data before loading into pig. Pig can be used to clean up the data in the following manner. So all right. Now, in the market of analytics, what percentage? I have no clue about this. We'll have to find out. Okay, we'll have to find out. But there are considerable amount of companies use pig. All right. So this is clear to all, right? Is this clear to you? This particular example? All right. There is a question from Webov. So the baseball file in the earlier example could also have been done cleanup since yes, that's correct. Okay. In when we are working on the production, most likely we'll do the cleanup first and then do any analytics on top of that. Okay. So is this example clear or this example? if you haven't gone through my regex session, please go through it. It's in the session 1 page of your LMS course detail page, session 1 tab. All right, so there, just go through the regex and probably that'll be quite a useful thing for you. All right. Okay, so that was the list of functions. So go through this function list, and a lot of cleaning of the data can be done using pig. And on top of this cleaned data, you could run various kinds of tools such as Mahout or other kind of tools to clean up the data, maybe mllib, maybe Spark, or maybe something else on the cleaned data. All right, let's take a break for 10 minutes and back after 10 minutes. All right, so we'll be back by 8:49 a.m. IST. Right. So I think we should start. Is everybody back? All right. Vaibhav, Leonid, Kiran, John, Deepak. Should we start now? Good. Let's start then. All right. There we have a question from Kiran. Kiran is saying that he is trying to practice on his Cloudera VM, and in case somebody else is having the same issue, it may be useful. So, although I would strongly recommend that you use Cloud Labs, okay, but still, if you are trying it on your local machine, what you can do is you can go here and then you can say download, and not hit this way. You can, okay. So, all right, you'll have to, I think, download the full folder. Yeah. So there is on Windows, you don't have a way to, yeah, you can't download multiple files in a single shot. What you can actually do is do a Hadoop copy local, then zip, and then download. Okay. So you will have to download one file at a time. All right. All of this data is available in this folder. You can use that. All right. And I'm just sending that to everyone. All right, Kiran. Basically, you can download one file at a time, Down- And all right, so we talked about load, store, and for each. The next one is group by a particular field. You can group the data just like in SQL. So what does it mean by grouping? Bringing all the values for a key together. Say, for example, when we say dump, we have A, which is this, and if we group it by a particular field. Let's say the second field, say age here, and so if you see, A has got these column name, age, and GPA. So when you group A based on age, which is the second column, what happens is all the people who has the age equals to 18, that is Joe and John, these two tuples will become a part of a new map. Okay, you can see that, not map, it's a bag. So these two tuples come together, form a bag that becomes the value. And in cases there is only one person who is having a particular age, then there will be a bag but with only a single tuple. All right. So pay close attention to the data types and their names. So whenever you group based on a column, automatically there is a new column created with the name called group, and there is another column. The name of that column is same as whatever data set are you trying to group. If you are grouping A, the name of the second column will be A, and it will be basically a bag of tuples containing all the tuples of from A having the same value here. Okay, so I hope this is very clear, the data types. So whenever we are grouping a data set, it creates two columns. First one is the field on which it has been grouped. Second one is the bag of all the tuples having that particular value. Okay, so that's what it means by grouping. So this is just an example. Here we are saying we can group by a particular field, F1 and F2. But here this actually operation is happening in here. Okay. So A is being grouped by age. Okay. This is just for some uh, other example. This does not belong to here. All right. So pay attention to this part, the third statement. Okay. So is it clear to everyone what is grouping doing? All right. Now, opposite of group is flatten. Flatten converts back the groups into a normal rows. Okay. For example, let's say after grouping we reached to Sandeep, and then there is a collection of values. These are the, say, languages which Sandeep knows. These are the languages which Arun knows. These are the languages which Chintamani knows, so Seemani knows. So if you have to convert it back into something like Sandeep C++, Arun Cell, Arun C, and so on, so that you can apply other kind of operations as well. So you could basically say, for each X, generate name, and then we can say flatten languages. Flatten languages. Now we'll get this kind of output out of this. All right. So flatten is just opposite of group by. Next is filter. So whenever you want to only have we want to select only few records based on certain conditions, we can apply filter. For example, let's say we only want those symbols or those stickers where the name matches, symbol matches cm dot star. Can anybody tell me what does it mean by cm dot star in a regular expression? What does it mean, cm dot star? Anyone? In a regular expression, what do you mean by cm dot star? Correct. It means, correct, Matthew, thank you. And yes, Kiran, dot means any character, and star means any number of any character. Okay, so dot star means any number of any character. So have a look at the regular expression session again. So you will keep on seeing this regular expression again and again, because all across these data churning technologies, knowing regular expression is very important. Okay, so basically it means cm dot star means anything that starts with cm. Okay, it will also match cm itself, because dot means Dot star means zero or more of any characters. So that means it will match CM also. Now we could say filter divs by symbol matching this. We can try that out right away. Did it work? I think it did. All right, let me try to do this. And then dump starts with CM. Let's see what happens. So it's going to filter the data, filter the divs by this particular symbol, and whatever is the result is going to dump. Next is the negation. So you could apply any kind of conditions on a data set by using filter, and those conditions you can have more look at. These conditions can be A matches B, A less than or greater than something, and something else, or we could put not as well. So we could combine these conditions in a boolean way by and, or, not, and the usual boolean operators. Okay, not, I mean, we also call them the logical operators. So you can concatenate, you can have multiple conditions chained together using these logical operators. So you can see that all these symbols are starting with CM, CME, CM itself, CMP, and CMU, and so on. Okay, so using filter we can only select few records matching our condition. So Matthew's question is, can we also filter by this? So if I understand correctly, it means from the beginning of the line, right? And here it's we are not searching for a expression inside a string. We are basically matching it. So by default, any regular expression you are putting is trying to match with the whole column. All right. So you don't need to put the beginning of the line. This caret character is for the beginning of the line. It's not really required because the matches one matches with the full content of a column. Okay, so if you want to say not, yes, you could say if my if you say this, it means not of C or M. Okay, these are two characters, and these are character ranges. So it means that it is not C or M. But the correct way of doing it would be saying correct way of doing it would be this one. Okay, this is the correct way. Because that one, if that's not a proper regular expression, if you put like this, even that is not going to work, because this means either of the character C or M if you put in the brackets. Okay, therefore you need to use the logical operators. All right. Okay, so these are the various conditions. You can see that we have not symbol matches with dividend greater than some value, less than some value, or dividends greater than zero point 0.4. So such kind of complex conditions can be used. And let's try to say dump result. So, okay, Matthew's question is all right. So, I think a better way to explain to you is, let's say we have CM, okay, and we are saying control searching in this. All right. So, we could, if we say not of C and M, and from the beginning of line, from the end, it will not match anything. Okay. But if we have X, Y, Z, C, M, then it will match some things. Okay, now you can see it is matching X, it is matching Y, it is matching Z, it is not matching C or M, it is not matching CM. Now you understand what does it mean? Okay, so please, if you have gone through the regular expression, try to go through it again. Uh, it'll help you because in case there is a doubt with regular expression, feel free to write to me at Hadoop at No Big Data, and I'll try to help you with the regular expressions. Okay. 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 All right. Okay. So whenever we say this, okay, we basically mean that not of C or M, because this means C or M. Okay, so it'll match C or M. You can see that it's matching C or M, line number 5 and line number 6. But if you put the negation, it means neither of the characters. All right, so yeah, you can work on the regex. All right, so question to you is, will there be any reducer generated for filter divs by symbol where symbol is matching a particular character? Anyone? So Matthew says no. So will there be any reducer side code generated when you run this statement? Correct. It's just a filter statement. So there is no need of any regular expression, any reducer. There is no need of any reducer. Why? Because you can do that. You or pig can do that on the mapper side. Okay, you don't need to have any reducer side code, right? Next is the order by and distinct. So order by orders your dataset by a particular field or by multiple fields. By default, the ordering is ascending. You can change that to descending by putting DESC after the symbol. And in distinct, you can generate the distinct number of symbols by using unique symbol equals distinct. Distinct is the keyword in the game. Okay, so you can use distinct for generating generating only the unique values. Okay, so you can combine for each and distinct together. So use for each to generate only one field and use distinct to generate the distinct symbols. Okay, now again same question, will it generate any reducer side code? Unique symbols equal to distinct symbols. Do you think it will generate any reducer side code? Anyone? So if you had to do the same thing, can you do the same thing without having reducer, or will you use reducer in your map reduce phase? So Leonid's point is yes, but the distinct will have to work across nodes. That is correct. Kiran is saying we can use sort in the mapper, but how will you do that? Because if you try to do the sorting, so let's say in case of a mapper, because mapper will run on only subsets of the data, so you cannot really compute the distinct unless you have a reducer. Okay. Uh, so Kiran is saying if we write Java mapper, we can do it by comparator. But uh, so see, if you write your mapper, right, your mapper code is going to run only on one node. Okay. So unless you have a reducer side code, uh, if you turn off the reducer completely, how would you generate the distinct values? Okay. So yes, there will be the reducer. All right. Next is Next are the joins. Joins are very important in case of any data churning because doing the joins using our usual procedural or any programming language is a very big headache. Okay, it's a very time consuming thing for doing the joins using procedural language. If you remember, even while using MapReduce, when we tried to join, it was too much of a task. Okay, remember our fifth problem of unusual democracy when we were trying to join two tables. Okay, so probably joins and these syntax is the reason why people use pig or similar languages for getting it done easily than doing it on MapReduce. Okay, so you can join on single key or composite key. So to join on single key, what you can do is you can load the data. Let's say you loaded data into two data sets. One is daily and devs, and then you can simply join daily by a column and devs by a column. So if you remember properly, meaning of a join is when you have to join two data sets, it means that we are trying to pick up the two records from both the sides which have a matching key. Okay, or one or multiple from both the sides which have matching key. So we are joining those records. Sometimes you have to join based on multiple columns. So when we say join daily by exchange symbol and devs by exchange comma symbol, it means that daily dot exchange and daily dot symbol are both matching on the devs dot exchange and devs dot symbol. For each record which will come in the result, these two conditions will be true. All right. So if you have to do the self join, it's not that straightforward in pig. You will have to load the same data twice and then you can join as if those are two different data sets. All right. Okay. Any questions on joins? So are the joins clear to you? So we are basically joining daily and divs where symbol from daily is equal to symbol from divs. We will get all only those rows from both the sides bunched together where this condition is true. All right. I think I'll show you an example. Also, the difference of joins from our traditional relational database, these are the two things which are very different. First, join should always have at least a column. The way we had in RDBMS, the joins may or may not have a column. If you don't have any condition or column on which you are joining, it will basically find all possible combinations or as in cross a Cartesian product of both the sides. But here, that's not the case. In case you do not provide a column on which we are joining, it gives an error. Second is, join cannot have conditions. We cannot say join a comma b on a dot value greater than b dot value as opposed to what we have in SQL. This is another big difference from RDBMS. All right. And can anybody tell me why is this a problem? Anyone? Why can't we join this way? Why can't joins have conditions like RDBMS? Leonid, Kiran, John, Deepak, Matthew, Vaibhav. Vaibhav says that it is not possible to distribute nodes. Okay, it requires multiple MRs. Okay, you are closer. Matthew says, I don't know. Okay, think about think about the same thing in terms of MapReduce. Think about how would you do it? Can you do something like can you join two tables A and B based on A dot value greater than B dot value? Okay, Matthew says we would have to process the first before joining. The problem is, okay, where is my, yeah. All right. Basically, the reason is in map and reduce, you can only specify a key. Okay, which means we can only specify equality. All those values whose keys is same, they come together. That's why we are able to provide equality easily, but not greater than less than kind of operations. Correct. All right. So a join essentially means this. I think this diagram will make it clear to you. Let's say you have A, you have B. The A has got ID and name column. A has got ID and the name column, and B has got ID and the name. So when we say ID and name, I mean there are these two columns in A, and in B there are these two columns. So when you join A and B where A dot ID equals to B dot ID, that means we will only get one Sandeep and one Giri together like this. We will not get two Ryan or three Saha from both the sides. Okay. So Leonid is saying, is the issue due to A and B not initially being sorted? Right. So basically, when we have to join two data sets, the way we joined was we created MapReduce such that key from A and key from B uh, will come together wherever they are same, right? But that is not possible when we have a condition. All right. So this is clear to everyone. How does this join work? All right. So continuing to the usual join things, there are outer joins as well in Pig. And what does it mean by outer join? Or left outer joins? Left outer join means all the all the data from the left hand side will go in the output whether there is a corresponding ID in the right side or not. For example, when you join one Sandeep and two Ryan and do a left join with one Giri and three Saha, you always get one Sandeep and two Ryan in the output. While for the first record, we found the corresponding value on the right hand side, but we did not find the value for 2 Ryan, therefore that is blank. So this is called left outer join. It can also be abbreviated as left, and why it's called and the way to remember is when you put left keyword, it has to be on the left hand side of the comma. On the left hand side of this comma. Okay? Alright? So left means all the values from the left hand side, whether there is a corresponding value from the right or not, the all the values from left hand side will go in the result. Now similar to left there is a right, in which case if you put right, the keyword will be just before the comma. So it means that all the values from the right hand side would go in the output whether there is a corresponding value from the left or not. Okay, so here you can see there is no corresponding value from for 3 left in the left hand side. For three Saha, there is nothing on the left hand side. Okay, so is this clear? The left, right, and the joins are clear to you? Okay, so what if we say things like this? Join A by ID, right outer B by ID. Anyone? So can anybody tell me this, the answer to this? So we are doing right outer join of A and B. A contains one Sandeep, four Ryan, and B contains four Giri and three Saha. And we are doing a right outer join. Anyone? Okay. So Vaibhav says that one Sandeep. Let me just copy your one by one. So let me just see. Okay, web of says this. Web of, okay, and we have, all right. Now if you, okay, what else? All right. Okay, okay. So let me added the correct one. Okay. So, all right. Three Saha, four Giri, four Giri. But don't you think that four will match with Ryan here, this side? Now let me have a look at Leonid's attempt. So this is Leonid, four Giri, four Saha, and then we have, all right. Yes, that is correct, Leonid. So basically this will be the output. All right. Now you can see that. Okay. So first it will try to match the ID for 4. If it found somebody correspondingly on the left hand side, it will give that result. Then pick the next one. If it found somebody on the left hand side, it's okay, it will print. Otherwise, it will just put blanks over there. Okay. So is it clear, Deepak? So it'll be 4 Ryan, 4 Giri, blank blank, 3 comma Saha. Yes, Matthew? You're saying no makes no sense? Should I explain it once more? Yeah. So you can see here that clearly the way a right join works is we pick up the right side values, find out the corresponding value on the left hand side based on what is our ID on which we are trying to match. Okay. So question from Matthew is why would you do it in that anyway? So question is why do we require right join or left join, right? Is that your question? Yes, Matthew, is that your question? Or is the you don't find the approach correct? Yeah. What is the purpose of this? Okay, good point. Let me clarify the purpose of this. Okay, so this is important. Probably, I think I should clear the purpose of right join or left join. Okay, so let's say there are two tables. Let us say there are two tables, one containing the employees' names, second containing their records containing their uh, you know containing their payment details. Okay, when were they paid last time? So this payment details month wise. This payment details contains that in which month which employee was paid, right? Now, what you want to do is, first question is you want to find out who was not paid in August. Who was not paid in August. Okay? So if you try to do in any other fashion than without a join, then it will be a very big issue. Reason being, you cannot, if you try to do it that pick up things from the second table, try to find it whether it's there or not, and then try to match it, then it is going to be a very big mm, task. All right. So what you can do is you could do a right join, and then after doing the right join, we could find out who was not paid by checking for the blank value. Because if we do the right join, all the values from the right hand side, and I'm assuming the payment details table will be on the right hand side. And when we join the payment details table with the employee names, and it's a right join, so all the values from payment details will come whether there is a corresponding person or not. And then we can apply things like whether the employee detail is null or not. Okay, so basically using a right or left join, we can do wonders. We can do things like intersection of two sets, and all kind of operations you can do with left and right joins. Yes, so each table will have, say, ID of the employee and name of the employee, and then there will be ID of the employee. Let me call it employee ID, and month, when which month they were paid, and the amount. Okay, so now if you have to find out who was not paid in August, you will have to either say select star from from payment details, where where employee ID not in, or how should I say, select star from payment details where month equals August, and we can say select star from employees where ID not in, like this, right? This is what you are trying to say. So one way of computing this is this, which is horrible, because if this data is bigger huge, then this is going to be very, very ineffective. A better way of doing it is select star from employees, join payment details, okay, on on, or you can say right join, on employees dot id equals to payment details dot employee id. Okay, and whatever is the result of this thing, we later on can say and employees dot id is null. Now this will give you And we can also put conditions like and month is August. Okay, so using the right join, we can do wonders in this game. All right, and when you churn the data, you can do a lot of churning using left or right in, okay, left or right joins to to avoid various kinds of not in, and there are many use cases you will find. Okay, also if you are counting things and you want to display a zero as well against a name which is not found in the second one, we can do that using, all right. Okay, so yeah, so in case of databases, a right join left join are very much required, and we can discuss couple of more use cases. We can discuss couple of more use cases, all right, if you want. Moving on the similar lines, if you want to join both left and right in a single shot, you can do full join in this manner. We can say join A by ID full B by ID. So it is equivalent to whatever we could match from both the sides, we matched it. Say one Sandeep, one Giri has matched from both the sides, while two Ryan and three Saha will form the separate rows. Okay, are you with me? Yes. So it sounds like a union, Kiran, but it's not really a union. You will understand it when you look at the code of union. Yeah. But mm, as a mathematical union function, if you're talking about the set theory union function, then you're correct. This is basically a union of set theory. And okay, this is basically the union of the set theory. If you're talking about union in terms of the database union, then it will be a little different. All right. So we are saying when we say full, we are saying get the records from both the sides. Okay. And then get the record from left hand side which are not matching on the right hand side. And similarly, then get the record from the right hand side which are not matching on the left hand side. Okay. This is basically a union. All right, great. Now, moving on. Can anybody tell me the total number of records we will get when we do the full join? When we joined A and B as normal join, we got N1 records. And when we join A and B with a left join, we got N2 records. When we did A and B with the right join, we got N3 records. If we join A and B with full join, how many records will be there in the output? Anyone? Kiran, Matthew, Deepak, Vaibhav. Okay, so I missed one point from Matthew. So you are joining the name from table 1 and payment info from table 2. Here we are joining ID from table 1 with a payment with the table 2. Yes. Okay. So Leonid, let me go back and explain what does full means. So full means records from left hand side which are matching with right hand side. Okay, exactly. Say ID is matching, so that those will go in the output. Now the remaining one which are not matching from A, and we with the remaining one of A which have no corresponding items in B, those will go afterwards. And then we have the records from right hand side which have no corresponding IDs on the left hand side. Okay, so this is the intersecting one, the first one, and rest of the records. Is that clear, Leonid? All right, so good. And all right, so let me just read it out. Kiran says it will be n1 plus n1 minus n2 plus n1 minus n3. Okay, I think you are saying it n2 minus n1 plus n3 minus n1. Okay. Uh, yeah, yeah, you're correct, Kiran. Uh, I think he corrected it later. So Deepak says n1 plus number of ID matches in table 2. Okay, go ahead. All right, all right. So Vaibhav says this. Good, good. So this is Vaibhav's answer. Okay, okay. So this is Leonid's answer. Okay, yes, that is correct. So basically, whatever records we got when we did intersection in both the sides will be the one where it's the same. So which is where where records from both the sides are existing. That is N1. Second one where the records from left hand side is N2, which means only the left hand side without the intersection would be N2 minus N1. Only the right hand side would be N3 minus N1. So total would be N1 plus N2 minus N1, N3 minus N1, which is N2 plus N3 minus N1. Good, great, excellent. All right. So yes, that is how it is. All right. Next is the outer joins. This a question on outer join. So beware, it's a teaser. It's so don't get mad. It's just a teaser. It's not, you know. So we are joining A and B, and we are saying join A by ID, comma B by ID, left outer. What will be the result? Anyone? No answer? All right. So Weber is saying, okay. So the answer is that there'll be a syntax error. Okay, there'll be a syntax error because left or right need to come before this comma, which is here. Okay, the left and right has to come before the comma. So left or right, whatever syntax you want to put in, it has to be before here. Okay. Now another questions to you. One more question for you. So join A by ID outer B by ID, what will be the result? Anyone? Yeah. Deepak, John, Kiran, Leonid, Matthew, Vaibhav. Okay. Yes. So by default, it has to be. That's correct, Kiran. You need to specify. You need to specify the left, left or right. We need to specify. So outer cannot go alone. We need to mention either left or right. Okay. Although, although outer is optional, but left or right is mandatory. Okay. So these are very syntax kind of a problems. Okay. And yeah. Next is that you can limit your results to particular number of records. So you can say limit only to 10 records. So it will give you the first 10 records. And so this is similar to SQL. What is new is we could say things like give me only X percentage of total number of records. Okay, we can say sample div point one and it'll give us 10% of total records. And this will be a random sample instead of first 10 or middle 10 or last 10. It is going to be a random sample. Okay, so a sample basically gives you a random sample out of the input data, and this is very much of a significance when we are doing some computation or we are trying to measure, when we are trying to figure out what kind of data set we are talking about. Okay, so if we have a okay, so Leonid's question is, can randomizer be configured? Mm, Not really. The only thing you can do is you can tell it that these percentage of record is what I'm looking for. Okay, these percentage of record is what I'm looking for. Okay, now here is a good question for you. So I'm saying divs equals to load my tab separated data. I'm saying give me some small sample out of it, meaning 10% of data, and then dump some and dump some. I'm saying dump twice. I'm dumping the data twice. Do you think it will give the same result or it will give the different results? I loaded the data, I computed 10% of it, and then I dumped that twice. So these two dumps will give us the same result or different results. That's correct, Matthew. It is going to be different. So Kiran's question is, so from each block 10% records are taken? Yes. Okay. So yeah. So Kiran, the what happens is that when you say dump, only then the sampling will happen, and before sampling the load will happen. So the trigger of the whole action happens when you say dump. Okay? Nothing is cached. And sample, every time it's executed, it gives us different result. Correct. Correct. That's correct, Webhub. Thank you. Yes. So expression will be executed only when dump gets executed, and therefore sample gets executed twice. Even the load will get executed twice. All right. Is it? Does it make sense, Kiran, to you? Great. Great. So yes. All right. Weber's question is, will load be executed twice too? Yes. Unfortunately, it will be loaded twice. Because if you think about it, loading data does not mean really loading the data. It's just a syntax. Because here we are talking about terabytes of data. Imagine loading the data somewhere will unnecessarily cause a havoc. Okay? All right. So as we told earlier, that pigs fly, as in it's a basic premise of pig to do the job really, really fast. So pig gives you far more controls for the performance, as well as it takes many kind of assumptions to make your overall process little faster. And for that, the first syntax it provides you is parallel. Parallel means parallel is a keyword with which you can specify number of reducers. Although pig decides number of reducers by itself, if you do not specify number of reducers, it will automatically decide upon the number of reducers. Okay, but you can also control the number of reducers in the process. Okay, so when you are computing number of reducers, you can take care of things into account, like what kind of process is it, and how many nodes are there in the network. The way we mentioned number of reducers in our map reduce exercises, in the same fashion you can also mention the number of reducers by through a keyword called parallel. So you can attach the parallel keyword after group by, after filter, after all of these you can attach the parallel keyword. In case in case you want to set a default in your script, you can begin your script with set default underscore parallel and then mention a number. Okay, so Leonid's question is that can you explicitly specify zero number of reducers? I don't think that you can do it, and maybe I'll have to try it out, or maybe you can try it out. All right. Okay. So by default, if you do not have parallel, if you do not mention that you want to specify number of reducers, pig does a reasonable amount of assumptions. For example, here, in case pig has to decide the reducers, so for each gigabyte of data, it creates one reducer. If you have 10 gigabytes of data, it will create 10 reducers. If you have 50 gigabyte of data, it will create 50 reducers. Okay, but it does not create number of reducers beyond 999. So if you have if you have say 1 terabyte of data or 2 terabyte of data, how many reducers will it create? Anybody? If you have 2 terabyte of data, how many reducers will pig create? Yeah. Yes. So it will be 999. Thank you, Leonard. And Vaibhav? Yes, it'll be 99. All right. Again, a little bit a teaser question again. So if we have this syntax, how many reducers will it produce? Okay. So Leonid's question point is number of reducers cannot exceed number of data nodes. That's correct. Yeah. Okay. Unless we are talking about number of reducer tasks. Okay. Number of reducer tasks can, when we specify number of reducer tasks, that they can exceed number of nodes. Okay. Reason being that on one machine you can execute multiple tasks. If you remember our discussion earlier, we said that we will find out how many tasks can be executed on each node and then multiply that number by total number of nodes. That is the maximum capacity of your cluster. So maximum capacity is the one which cannot be exceeded. Okay. So number of reducers cannot exceed the number of tasks that can execute on data nodes, which is equal to data nodes into total number of data nodes into the total task that can be executed on each node. Awesome. Great. Now question to all of you is how many reducers will it produce? Quickly, anyone? This is a straightforward question. Yeah. Vaibhav, Leonid, Matthew, Kiran, Deepak, John. Okay. So it will not have any reducers. That's correct, Vaibhav. It will not have any reducer because it's a for each. Okay. By default, in case of our usual MapReduce, there used to be one, but we should generally turn it off because we don't require reducers in these kind of scenarios. We don't require any sorting. All we require is iterate through the data set, and all we require is mapper. Is that clear, Matthew? Okay. So now the question to you is, will parallel clause have any effect in this? Yes or no? Will parallel clause have any effect in this? Anyone? Anyone? So does parallel clause have any effect on this? Yes, that's correct. The parallel clause will have no effect at all in this kind of scenario. Reason being, when there are no reducers, that means there is no effect of parallel clause at all. Okay? Means parallel clause makes sense only in those scenarios where there are number of reducers. All right? Okay, so that's pretty much for today. We will continue from here in the next session. And the Next session will be little bit more advanced when it comes to pig. Okay. Okay. We will talk about how to create your own UDF. All right. Thank you, Matthew. Thank you, Kiran. Thank you, Vaibhav. Thank you, Deepak, John. Thank you, Leonard. Have a great day and see you next week. So there'll be an exercise. There is an exercise in the LMS. Whatever we have learned so far, that is good enough for solving those exercises, both quiz as well as the subjective question. So do not miss on that. So finish those exercises. It will be very useful to you. All right. Great. Thank you very much. If you have any question, all of you, if you have any question, feel free to drop me at hadoop at nobigdata.com. Oh, all right. Great. Have a great week ahead and see you on the next week. Bye bye.